Now, if this container is moving upward acceleration with same magnitude, let us say g, in that case what happens? If you look previous equation, instead of container falling freely, container is accelerated upward. Suppose we have a container kept in some lift, and lift is moving upward with acceleration g. That lift is moving upward with acceleration g. Then del p over del z will be equal to minus rho g plus g. So, it will become 2g. It means del p over del z is equal to minus 2g rho or minus 2 gamma. So, in this case the pressure gradient will be twice of without any acceleration. So, if you look at this figure, in this figure we have a pressure force at this point P2. This P2 is equal to rho gh under normal condition. If this container is at rest, if container is not moving, then P2 is equal to rho gh plus P1. If P1 is considered as atmospheric pressure, so we can neglect if pressure is equal to gauge pressure. We know that if pressure is measured with reference to the atmospheric, then it is called gauge pressure. So, P2 is equal to rho gh. But if this container is accelerating in this direction, this whole container I am talking about, this whole container is moving in this direction, and this acceleration is g, upward acceleration is g. It is put in a lift, and this lift is moving upward with acceleration g. In that case, what happens to this pressure P2? This P2 will become twice of rho gh. So, it means that because of acceleration at this point, this pressure will go up. So, that is why whenever we have to design the container which is subjected to acceleration, if it is this pressure on bottom side is twice of the previous case, it means that the force on the bottom side is also gone up. So, that is why to withstand that force we have to give additional strength, so that this container can withstand that additional pressure coming due to the acceleration of the container in upward direction. So, we have to keep these things in mind whenever we are designing a container which is subjected to acceleration in different direction. So, what type of force will develop due to acceleration of the fluid, and correspondingly we have to find out the suitable thickness of the wall, so that it can withstand the pressure being exerted by the fluid on the wall.